Hello guys, trust you are doing fantastic. So in today's video, I'll be talking about Arduino hardware. I'm going to recommend that you hold your Arduino board in your hands if you have one, and also pause this video to take a closer look at the Arduino board you have in your hands as we discuss the different parts. I want you to understand that Arduino Uno is the baseline Arduino board. In my previous video, I explained to you that there are different derivatives and clones of the Arduino board. Whichever one you have in your hands, it will work just fine. Alright, so before we go in depth into today's topic, I would like to also explain to you the different concepts we'll be talking about in this video. The first, we'll look at the concept of an Arduino board. We'll also talk about the pin header rows, which has three divisions: the digital, analog, and power. And then we'll also talk about other stuffs, as well as the barefoot skying tricks. The basic concept of Arduino board is designed around the microcontroller. The microcontroller is nothing but the IC, which is the integrated circuit. This is the brain behind the Arduino board. It is the Atmel AT-MEGA328 microcontroller. So right now, don't worry about the fancy name. It doesn't matter. What does matter is understanding that everything on the Arduino board is meant to support the integrated circuit, which is the microcontroller. Now, if you take a closer look at the microcontroller, you will notice that it has little metal pins that stick out on both sides. These pins are how the microcontroller is able to interface with other hardware like the LED, the sensors, and even the computer. The pins run through the microcontrollers. Now the question is, how do we use these pins? How do we use them? How do we actually connect anything to them? Now, this is where the pin headers come in. The pin headers has three sections. The pin headers are these plastic rows of holes that stick up from the Arduino board. Inside these holes are little metal clips. These little metal clips clamp onto a wire when they are stuck into the hole. Now, the metal clips inside the hole make electrical connection between the wire and a specific pin in the microcontroller. So this is how the microcontroller connects with everything that is connected to the board. This connection is achieved via the pin header. So this is how connection is made between the pins of the microcontroller and the header. The pin headers is divided into three categories. Now the first category I'm going to be talking about is the digital pins. Okay. If you notice, the digital pin is the longest. They are used as input or output. And when they act as input, they only read two different voltage states, either high or low. And when they act as output, they only output two voltage states, either 5 volt, which is considered as high, or 0 volt, which is called low. Now there is an exception to this. If you notice, some pins here have little mark next to them. These are pins where you can use a technique called pulse width modulation, or PWM. Now we'll be talking about this much later. Now, take a closer look. You will notice that there are 0 up to 13 pins. Now, the little mark on some of these pins can be identified on pin 3, 5, 6, 9, 10, 11. So these pins are pins that you can apply the PWM, which is the pulse width modulation technique. We'll be talking about this in our later videos. Next is the two pins I want to talk about, which is 0 and 1. Now if you notice, they have TX and RX next to them with these little arrows. That stands for transmit and receive. These are the pins that the Arduino uses to communicate between the computer. When you're uploading a sketch, for example, you are doing serial communication between the Arduino and the computer. Now, on the same board, you will notice there is another TX and RX, which also complements the previous RX and TX. Now, what this means is each time the Arduino is communicating with the computer via serial communication, the light blinks, which indicates that there is an establishment in communication between the computer and Arduino. So it shows that the connections are correct. We will learn more about serial communication later in this course. It is a good thing to know upfront. Next, I would like to talk about is pin 13, which is actually worth talking about. That is where there is an onboard LED attached, and you can use that LED as though it were externally connected through a resistor to the Arduino. So the next segment of the pin headers we want to talk about is the analog. Now in Arduino, the way microcontroller handles input is by using the tool called analog to digital converter, or simply ADC. And this ADC is part of the integrated circuit, meaning it's built into the microcontroller. These analog pins, which runs from A0 to A5, have access to this ADC converter, which is built into the microcontroller. How ADC works? Now the ADC takes all the variations in analog signals. These analog signals are actually created when you connect your sensors to your Arduino board. It takes all of these signals and then cuts them up into these discrete steps. Analog pins can act as both input and output, just like the digital pin. We will talk more of ADC in the subsequent videos in this course. The next segment of the pin header I want to talk about is the power pin header. Now if you take a closer look at the power pin header, you're going to see the 5V, which is the 5-volt pin. This pin provides 5 volts when you connect the Arduino to a computer, either through using USB cable or you're using an external battery power source. Then this pin can provide 5 volts to a circuit. There is also a pin which is 3.3 volts, which is next to the 5-volt pin. This pin also provides 3.3 volts to the circuit. There is another pin which is next to the 5-volt pin, which is labeled the GND pin. This pin stands for the ground. These pins give access to the lowest voltage on the Arduino board, which is 0 volt. And the ground pins are all 1. Now if you notice, you have 2 ground pins. They are all 1 and they are connected to each other. There is another ground pin on the Arduino board. This pin is also connected to the ground pin attached to the power pin header. They are connected to each other and they are all 1. Next, I want to talk about is the reset button. Now this reset button, what it does is that when you press this reset button, the current program that is running will start back from the beginning. Let me bring something to your notice. When this reset pin is pressed, it does not erase the program. It only resets the program, meaning that the current running program will have to start back from the beginning. The next thing I want to talk about is the reset pin, which is located in the power pin header. This pin functions exactly like the reset button close to the digital pin header. How this reset pin works is that if a low voltage is applied to this pin, it will do exactly the same thing like the reset button, where the current program will start back from the beginning without erasing the program. The next pin I want to talk about is the power pin. Sometimes it's called the power on LED. It turns on whenever power is applied to the Arduino. This is the end of the lecture in this video, so pay close attention to the subsequent videos in this course. Alright then, enjoy this video. Bye.